Greetings, respected faculties. Today, we will be presenting our project by Group 4, and the title is Loan Eligibility Prediction Using Machine Learning Models with Smart for Class Imbalance. The main motivation behind this work is that loan eligibility plays a very important role in the banking industry. Traditionally, banks use rigid credit scoring systems to decide whether a person qualifies for a loan. However, these conventional methods are often inefficient, unable to adapt to changing financial patterns, and may even overlook deserving applicants. This is where machine learning comes in. By applying advanced ML algorithms such as random forest, logistic regressions, AdaBoost, k-nearest neighbors, and multi-layer perceptron, we can build predictive models that are more accurate, flexible, and fair. In our project, we also applied SMART, which is a technique to handle class imbalance, ensuring that the models do not become biased toward the majority class. Through pre-processing, feature engineering, and testing, we found that models like random forest and MLP, that is multi-layer perceptron, provide the most promising results in terms of accuracy and recall. Thank you.
Hello everyone. I will be presenting the literature review and methodology of our research. In the literature review, we found that traditional credit scoring systems are often rigid and limited in their ability to adapt to the changing nature of financial data. Many researchers have explored machine learning approaches such as logistic regression, random forest, support vector machines, and ensemble techniques like AdaBoost and XGBoost. Their findings consistently show that the ensemble methods outperform single classifiers because they can capture complex interactions in the data more effectively. Another key issue repeatedly highlighted in the previous works is the problem of class imbalance, where the number of approved and rejected loans applicants are unequal. Studies have shown that applying balancing techniques such as MOT improves both fairness and predictive performance. Building on these insights, our study is combines multiple machine learning models with SMART to address this challenge and ensure reliable predictions. Now let's go for the methodology. Moving on to the methodology, our dataset was obtained from the Dream Housing Financial Company. It contains applicant information such as the gender, marital status, education level, income, loan amount, property area, and credit history. We began with data processing. Missing values were treated carefully. For instance, missing loan amounts were replaced with the median, while missing categorical values were filled with the mode. After that, categorical variables like gender, education, and marital status were converted into numerical values using one hot encoding, so that they could be processed by machine learning models. Numerical features include applicant income, co-applicant income, loan amount, were normalized to bring all the values into the same scale. Finally, we applied SMOD to address the imbalance between approved and rejected loans by generating synthetic samples for the minority class. This step ensures that our model did not become biased toward the majority class. After pre-processing, we moved to the learning phase. We trained the 5 different machine learning models: random forest, logistic regression, AdaBoost, k-nearest neighbors, KNN, and multi-layer perception. Random forest, being an ensemble of decision trees, is very effective in reducing outfitting and handling complex datasets. Logistic regression, through simpler, provides interpretability in binary classification problems. AdaBoost works by combining multiple weak classifiers into a strong one and is especially useful for handling difficult cases. K-nearest neighbors, KNN, classifies applicants by comparing them with the most similar applicants in the dataset. And finally, multi-layer perception, which is a type of neural network, is capable of learning complex nonlinear relationships in the data. In the evaluation phase, These models were compared using accuracy, precision, recall, and F1 score. These metrics gave us complete understanding of how well each model predicted loan eligibility, especially in distinguishing between eligible and ineligible applicants.
Hello everyone, I'm here to talk about our findings on machine learning to predict loan eligibility. Our goal was to find the best model for this task by training and comparing different models. First, let's talk about the important factors in our dataset. We found that a person's applicant income, loan amount, and credit history are the most significant features for predicting if they are eligible for a loan. These make sense, as these are all key financial indicators. For instance, a higher income often allows for a larger loan. On the other hand, we discovered that features like gender, marital status, and self employed status had very little impact on loan eligibility. Next, we evaluated our five models: random forest, logistic regression, AdaBoost, k-nearest neighbors, and multi-layer perceptron. We looked at their performance using several matrices, including accuracy, precision, recall, and F1 score. The random forest and multi-layer perceptron models were the clear winners, both achieving an impressive 89.29% accuracy. The random forest model was particularly good at identifying eligible applicants, shown by its high F1 score of 0.94 for the true class. The MLP also performed very well with an excellent recall of 0.96 for the true class, meaning it successfully identified almost all the qualified applicants. However, we did notice a significant issue. Most models struggled to correctly identify ineligible applicants, or the false class. For example, the MLP model had a precision and recall of 0 for the false class, meaning it completely failed to identify any ineligible applicants. Similarly, AdaBoost had also a score of 0 for this class. The logistic regression model had the weakest overall performance, with only 75% accuracy. In conclusion, our research shows that machine learning is a powerful tool for predicting loan eligibility. The random forest and multi-layer perceptron models stood out as the most effective, both achieving high accuracy. We were able to handle the imbalance in our data using a technique called SMOT, which helped improve our models. The key takeaways is that applicant income, loan amount, and credit history are the most crucial factors. While our best models performed very well in predicting eligible applicants, there is still a big challenge in accurately identifying those who are ineligible. This is an area for future improvement. This study provides a solid foundation for companies like Dream Housing Finance to automate their loan approval process. By using data driven methods, they can improve efficiency and reduce risks. For the future, we could explore including more data like transaction history and also focus on making sure the models are fair and ethical, which will ensure they don't discriminate against certain groups. Thank you.